Okay, we have some more examples here of solving inequalities. And so here we're just asked to give the interval notation. If you still want to draw a number line, if that kind of helps you, that's fine. But on these examples, we're just going to focus on finding the interval notation. So let's see, what's going to be different here from the previous ones is we are going to see the variable appear in multiple places. And we have all the tools for this. We've done this when we were solving our linear equations. The only difference is now these are linear inequalities. So most of the rules are the same. There are a couple differences that we've seen in previous videos, and that might come up here a little bit. So first thing I want to do is isolate the variable to a single side of the inequality. So I could subtract 3x from both sides or 8x. I'm going to go ahead and subtract 3x from both sides. If I were to subtract 8x, that would be okay. It would look a little different as I work through it, but we would end up with the same result at the end. So let's see, I had 8x, take away 3, that'll leave me with 5x, and then I have that minus 1. And now I want to isolate that variable completely. So I'll go ahead and add 1 to both sides. So now let's see what we got. We're going to have 6 is less than or equal to 5x. And then we want to divide both sides by 5. And so I get 6/5 is less than or equal to x. And you want to be pretty good at reading this in both directions. This also could be read as, if I read it from right to left, would be that x is greater than or equal to 6/5. And so values that are greater than would go towards infinity. So my interval notation would be values from 6/5 and greater, which would be towards positive infinity. And so if you did need to draw a number line to help you out there, that's fine. But we're kind of hoping that at this point, we're kind of getting a little bit more comfortable with this. And so we can tell by just looking at our inequality. Okay, let's try another one. Okay, so once again, I have the variable appearing on both sides. And so I do have two approaches I could do here. I could add 2x to both sides, which wouldn't be a bad idea. It would keep my variable positive, and that, that's one approach. But I'm going to go ahead and subtract 2x. And the reason why is I want to review what happens when we have a negative variable. So we're going to cancel this out, and I'm left with negative 4x plus 20 is greater than, I'm left with that positive 4. Then we're going to go ahead and subtract 20 from both sides of the inequality. Cancel that out. And let's see, that'll leave me with negative 4x is greater than negative 16 when I do 4 take away 20. Okay, so here's that rule that I was alluding to. So I'm going to divide both sides by negative 4. And when I do that, that causes a sign change on both sides of my inequality. And so I'm going to have to reverse the direction of my inequality symbol. So now I'm going to have x is less than, instead of greater than, now it's less than. And then negative 16 over negative 4 would reduce to a positive 4. And so there's my inequality. And then I do want my interval notation. And so we want to come up with an interval that represents all the values that are less than 4. Well, numbers that are less than 4, well, all the negative numbers. So we're going to go negative infinity up to 4, and we have to use a parentheses because we do not include 4 as part of my solution set. And so there we are. Okay, a couple more of these. Okay, so once again, we've done all this stuff when we were solving equations. The only difference now is that we're dealing with inequalities. And so I'd have to start by distributing that negative 7. So I'm still going to have the negative 21x minus 10 is less than or equal to negative 7x. And then this will become a plus 7 when I distribute it and multiply it by the minus 1. Okay, now this one looks a lot like the previous two. So once again, I have two options. I could keep my variable negative by just adding 7x to both sides, or I could add 21, which I'll do this time. I'll kind of go back and forth. So I'm going to add 21x to both sides. I'll cancel that out. I'll be left with negative 10 on the left side. And then let's see, negative 7 plus 21. So now my variable gets to stay positive. So that's one way of kind of approaching this, is always trying to keep your variable positive. Um, Sometimes you can't avoid it, so you definitely want to know what that rule is. Okay, so then our next step would be to isolate the variable. So we'll subtract by 7 on both sides. So we cancel that out. So let's see, we're going to have negative 17 is less than or equal to 14x. And then we want to whittle this down to a single x. We don't want 14 x's, we want 1x. So we're going to divide by 14 on both sides. And so let's see, that's going to leave us with negative 17 over 14, which I'm not going to be able to reduce, is less than or equal to x. Or you could look at this as saying x is greater than or equal to negative 17 over 14. So remember, now we're talking about we want values that are greater than this. Well, greater is going to be to the right, less is left. So that might be a little trick to help you remember. If it's greater, you're going to go to the right. If it's less, if it's going to be less, then you're going to go left. So that might kind of help you a little bit. But this time it's greater. So we're going to go from, and we're going to bracket it in because we do have the equals to part right here. We're going to go from negative 17 over 14 to infinity. And like I've said, if you want to do a number line, just kind of help you, no problem with that. All right, I think I got another one kind of similar to this one where we have to do a little cleanup. We got to do a little cleanup here. So we're going to distribute the 2 here and here. And then the negative 2 we have to distribute on our other side over here. And then we'll kind of see what we're dealing with after that. So let's see, we're going to end up with negative 8x minus 2, and then we have that plus 88 is less than or equal to, and then let's see, negative times a negative, that will become positive 6x. And then once again, a negative times that minus 5 will become a plus 10. And then we do have that plus 5x over here. So I can do a little bit more cleanup. Sometimes I like to draw a line to kind of differentiate my two sides just to be careful. So anything on the left side of this green line I can combine if I have any like terms, and I do. I have the minus 2 and I have the plus 88. So I still have the minus or negative 8x, and then this will simplify into plus 86. And then on the other side, I have a 6x and a 5x that I can combine to give me 11x. And then I do have that plus 10 right there. Now we need to isolate the variable to a single side. So we can either subtract 11x from both sides or add 8x to both sides. I personally like to keep the variable positive, so I'm going to add 8x again. So here we go. That will cancel out. So then I'm going to have 86 is less than or equal to 19x plus 10. Then we'll go ahead and subtract by 10 on both sides. And that will leave me with 76 is less than or equal to 19x. And fortunately for us, this should divide out quite nicely when I divide both sides by 19. Divide by 19, this will actually reduce down to a 4 is less than or equal to x, or you could look at it as being x is greater than or equal to 4. And so when the numbers we're looking for are greater, we're going to the right. So it's going to be from 4 to infinity, and we bracket in our 4 right there. Okay, let's see, a few more. Ooh, this looks interesting. So it looks kind of bad, but we're going to make it a little bit easier to work with. And once again, we've actually done problems very similar to this when we were dealing with linear equations. The only difference is we have the inequality symbol here. So the LCD between 8, 3, and 24 is going to be 24. And so what we're going to do here is we're going to multiply both sides of the inequality by 24. And in my previous videos on this, what I tell you is don't actually distribute it yet. I wouldn't actually multiply everything by 24 yet. What I want to do here and I'm going to try to color code this a little bit so we can see this. I'm going to have 24 times b plus 12 divided by 8, and then is less than or equal to, and then I have that 24 that I'm multiplying by the b plus 6 here divided by 3, and then plus we'll have 24 times 7 divided by 24. And so the reason I don't want to distribute yet is because the 24 is going to reduce with each denominator individually to where I won't have these fractions any longer. So looking at the first one, 24 divided by 8 is going to give us a 3. So we're going to have 3 times b plus 12. So we will have to distribute in a moment. And then less than or equal to 24 divided by 3 in this case would be an 8. And then times b plus 6. And then plus the 24s cancel out to where I'm just left with that 7 right there. Okay, now at this point, this hopefully doesn't look too bad. It looks kind of similar to some of the others we've already done. So we'll go ahead and distribute here and here. So we're going to get 3b plus, let's see, what is that going to give us? 36, less than or equal to 8b plus 48. And then, don't want to forget my plus 7 right there. Then I can clean up that on the right side. I have like terms of 48 and that plus 7. So let's see, we'll have 3b plus 36 is less than or equal to 8b plus 55. Okay, so this time I'm going to do this one a little different because so far I've been keeping my variable positive, but in this case I'll approach it to where my variable will become negative, just so we can kind of review that again on what happens. So what I'm going to do here, I have to isolate the variable to one side by either removing 3b or 8b. This time I'm going to subtract 8b, just so we can see what happens when we get a negative variable. So let's see, we'll get negative 5b. Then we still have the plus 36 less than or equal to 55. Then we'll go ahead and subtract 36 from both sides of our inequality. And so we'll cancel that out. So we're going to have negative 5b is less than or equal to, looks like this is going to be negative 19. So then we'll divide both sides by negative 5, and this is where you have to be careful. We are going to reverse that inequality symbol. So now, when we cancel that out, we're going to have b is greater than or equal to, and then the double negatives here, this will become 19 over 5. So b is greater than 19 over 5. So we're looking for numbers that are larger than or greater than 19 over 5. So we're going to go towards positive infinity on this one. All right, I have a couple more, but we'll do that in the next video.